All right, here's the last video from 4.1 where we deal with exponential functions. In all the previous videos, we were given an exponential function and then asked questions about that exponential function. So in the most recent video, after being told the function itself, we were given an input and asked to find the output, or we're given the output and asked to find the input. But the key thing is that we've always been told what the exponential function itself was equal to. In this video, we're not going to be told the exponential function. We're going to be asked to come up with that exponential function. So we're given some information about the exponential function and supposed to use that to find out what the function is. So in order to be able to do that, what you need to know is that exponential functions always are of the form f of x equals a times b to the x power. So if we could just figure out what number was in place of a and what number is in place of b for a given exponential function, we'd have the equation of the exponential function. So it really comes down to, can you solve for a and b? You've actually done problems like this before, but you've only done it in the linear case. Maybe you've heard the phrase that 2 points determine a line. If you're given 2 different points and you were told that they lie in a line, you can come up with the equation of that line. You first solve for m, the slope, y2 minus y1 over x2 minus x1. And then once you have the slope, you can kind of plug that back into the formula to solve for b, the y-intercept. If that rings a bell, great, because what you're going to be doing is something kind of similar to that down here. We know that our equation is of this form, a times b to the x power. And because we're given these 2 pieces of information, what we really have are 2 points on the graph of this function. If f of negative 1 equals 3, this is saying when the input is negative 1, the output is 3. Therefore, the graph would go through the point negative 1, comma 3. And if f of 2 equals 24, that's telling us that when x equals 2, y is equal to 24. So we have these 2 points, and from 2 points, we can figure out the equation of the exponential function. What you want to do is first figure out what b is equal to, because once we figure out b, we'll be able to kind of plug back in to solve for a. And figure out b, it's a little bit tricky. I could give you a formula that you can just kind of memorize and plug in points to get, but most books don't teach it that way, and I'm not going to either, because I think there's a more intuitive way you can get it that teaches a technique that can be useful in other instances. So what you want to do to solve for b is a technique called dividing equations. And the way you do that, I'm going to write it as a multiple step process over here. What you want to do first is use the 2 points given to you in the problem to write 2 equations. And you might be like, what are you talking about, write 2 equations? Well, if I know that the function takes on this form, and I know that when x equals negative 1, y equals 3, I can come down here and I can change the x into a negative 1 and the output, the f of x, into a 3. So I could say that 3 is equal to a times b to the negative 1 power. And similarly, if I know that x equals 2 and y equals 24 as a point on the graph, then when y equals 24, the x must be equal to 2. So I get this equation, 24 equals a times b to the second power. So on these problems, you'll always be given 2 points, and those points can be given to you explicitly like this as coordinate pairs, or more in this functional notation. But either way, you'll have these 2 different points, and what you can do is plug those into the general form of the equation of an exponential function to come up with 2 equations that look like this. That's your first step. Your second step is to divide those 2 equations. When I say divide the equations, what I'm saying is if 3 is the same as ab to the negative 1 power, and 24 is the same as ab squared, then 3 divided by 24 has to be the same as ab to the negative 1 divided by ab squared. Right? If this is the same as this and this is the same as this over this is the same as this over this. So you divide the 2 equations to create a third equation. And you can divide them in whichever order you want. You can have 3/24 equals this over this, or 24/3 equals this over this. A little hint, it'll make the algebra work out nicer if you always take the larger value of x and put that on the top of your fraction. So since 2 is bigger than negative 1, I'm going to take this equation and make those the numerators, and this equation and make those the denominators. So on the left-hand side of the equation, I'll have 24 over 3, which is just 8, but I'm going to leave it as 24 over 3 so you can follow the steps. And then on the right-hand side, I'd have ab squared divided by ab to the negative 1 power. And this might look like a mess, but it's really not that bad. This will allow you to solve for b. Because what will happen is on one side of the equation, you'll just have a number, 24/3 or 8 in this case. And on the other side of the equation, you'll have an a in the numerator and an a in the denominator. You have to, because both the equations will come from these forms, so those a's can cancel out. So then all you're left with is b to the second power divided by b to the negative 1 power. And if you remember our video on exponent rules, you might remember that you can subtract those 2 exponents when you have the same base in your dividing. So 2 minus negative 1 is 3. So this will simplify all the way down to some number equals b raised up to some power. and then you could solve that equation for b. In this case, the way I'd get the b all by itself is I take the cubed root of both sides of the equation. So I get that b is equal to the cubed root of 8, and the cubed root of 8 is asking me the question, what number when I cube it gives me 8, and the answer to that question is just 2. So I get that b is equal to 2. That's not an easy process, and for a lot of students, that's a new process. But the good news is it's always kind of the same, right? It's always going to look like this, just with different numbers in these different places. And the algebra will kind of always work out this way, especially if you put the larger exponent up on the top. Note that if we had a smaller exponent up on top, if this was ab negative 1 over ab squared, then this would have been b to the negative third power, which just would have made it a little bit harder to solve for b down here. You still could have done it. You'd have b to the negative third equals 1 over 8 is how it would have worked out. And so you could have solved that equation for b. I'm just telling you it works out easier if you put the larger number up on top. Now that we have b, we can solve for a by going back to either of these two equations, it doesn't matter which one you choose, and plugging in the value for b. I'm going to choose this one because I like to avoid negative exponents whenever I can, but really you could choose either one. Step 4 is to plug back in to solve for a. So rewriting this equation with the number 2 in place of the b, I get this equation. And 2 squared is just 4, so I get 24 equals a times 4, or 4a. And if I divide both sides of the equation by 4, I get that a is equal to 6. Now that I have a and b, I have the equation of my function. Determine f of x. Well, f of x is a times b to the x power, where a is 6 and b is 2. In other words, f of x is equal to 6 times 2 to the x power. One more example, exact same thing, except a little bit quicker with harder numbers. Suppose you're told a function g is exponential, and g of negative 3 equals negative 3, and g of negative 1 equals negative 4/3. Well, you'd set it up the same way. You'd say g of x equals a times b to the x power, and because of this first statement up here, I know that when x equals this negative 3, y equals this negative 3. So I got negative 3 equals ab to the negative third power, and from this equation, I know that when x is equal to negative 1, so ab to the negative 1 power, y is equal to negative 4/3. I can tell you from experience that a lot of students switch the spots where these two go. They'll put the negative 4/3 up here and the negative 1 down here. So that's something to be careful of. Once I have these two equations, I just want to divide the two equations. It'll make your life easier if you take the equation with the larger exponent, negative 1 is larger than negative 3, further to the right on the number line, and put those on top. So I'd have negative 4/3 divided by negative 3 is equal to ab to the negative 1 power divided by ab to the negative third power. This is a little bit harder algebraically, but the same thing is going to work. The a's are going to cancel out. So on the right side, I'll have b to the negative 1 over b to the negative third. The left side's a little bit ugly, but a negative divided by a negative is a positive, so I could just ignore those two negative signs. And then if I rewrite 3 as 3 over 1, it'll make the algebra a little bit easier to divide a fraction by a fraction. On the right side, negative 1 minus negative 3 is positive 2, because negative 1 minus negative 3 is the same as negative 1 plus 3, which is 2. And then on the left side, if I take this 3 over 1 and I flip it upside down, I'd get 4/3 times 1/3, which is just 4/9. So b squared equals 4/9, and therefore b is 2/3. And you might be like, wait a minute, how'd you get from there to there? Well, I took the square root of both sides. Right, but when you take the square root of both sides, shouldn't you put in a plus or minus? Yes, but the value of b we talked about earlier is assumed to be a positive number, so we don't have to worry about the negative solution, and we can just say that b is equal to 2/3. Once we know that b is 2/3, we can plug that into either of these two equations to solve for a. I think this one will be easier because I don't want to raise something to the negative third power. So I would say that negative 4/3 is equal to a times 2/3, which is our value of b, to the negative 1 power. Raising something to the negative 1 power means take the reciprocal of it. So you can either write this as 1 divided by 2/3, or you can just write it as 3/2. Because 1 divided by 2/3 is 3/2, or because the reciprocal of 2/3 is just flip it upside down and get the 3/2. Now I want to solve this for a. Well, I multiply both sides of the equation by 2 and then divide both sides of the equation by 3 to get this a all by itself, and I get that a is equal to negative 8/9. I have the value of a and the value of b, so I have the values for my function. G of x is equal to negative 8/9 times 2/3 raised up to the x power. That's about as hard as you can make these problems, with negative numbers all over the place, negative exponents, fractions inside fractions. I really tried to make this one miserable, so if you can follow this example, you're an expert at this stuff. Before ending this video, I want to do one more example, and you're like, really? You're going to make this even harder? No, actually, I'm going to show you a little trick, and a little trick can save you a lot of time in some instances. The trick wouldn't have worked on either of these two examples that we've seen so far, because the trick only works when one of the two statements you're given tells you the value of y when x equals 0. So note that I didn't have a 0 in place here, or in place here or here. So I couldn't have used this little trick. This little trick only works when you have a 0 right here. And it's worth pointing out that in this case that you have a 0 right here, you could still do this the same way we've been doing them. You could still follow these same steps. It's still totally fine to set up two equations, divide the two equations, solve for b, plug in to solve for a. That will still work. However, you don't need to do all that because there's a quicker way. Look at what happens when I take this first statement and I start to write my equations. I know h is exponential, so h of x equals a times b to the x power. And this is telling me that when x equals 0, y equals negative 10. So I got negative 10 equals a times b to the 0 power. I don't know what b is equal to, but b to the 0 power, regardless of what b is equal to, has got to be equal to 1. We know that b is some positive number, and regardless of what positive number it is, when I raise it to the 0 power, I just get 1. So what that means is negative 10 is equal to a times 1. What I'm saying is anytime one of the two statements tells you the y value for an x value of 0, they're immediately telling you the value for a. Remember, these problems just come down to, can you find a and b? In this case, where x equals 0 is given, they're telling you the value of a. And once you have the value of a, you can plug that into the second equation to immediately solve for the value of b without doing any division at all. What I'm saying is this equation implies that negative 2/5 is equal to a times b to the second power, plugging in this for y and this for x. But if I know that a is negative 10, I can just plug in that negative 10. And now I have an equation that only involves one variable. So to solve that, that's easy. Just get that variable all by itself. Maybe first divide both sides of the equation by negative 10, which would give me fractions divided by fractions, which isn't ideal. So maybe instead, I'll think about it as multiply both sides by negative 1/10. That negative times this negative would make a positive, and I would have 2 over 50. In other words, 1 over 25 is equal to b squared. And now when I take the square root of both sides of the equation, I get b as plus or minus 1/5. But again, since b is assumed to be a positive number, I know b is equal to 1/5. So I can get my answer here without ever doing these steps where I divide the different equations. Again, to be clear, dividing the equation still works. You can totally do this method the old way. I'm just saying when one of the statements gives you the value of x equals 0, there's a quicker way to solve the problem, which is what I'm going for in this example.